Good morning, students. Already we have discussed about two quantum number, that is principal quantum number and azimuthal quantum number. Now this is third quantum number, which is called magnetic quantum number, and it is symbolized by ML. Now what represent by this quantum number? This quantum number is required to explain the splitting of lines in presence of magnetic field. As we have got in the drawback of Bose model cannot explain about the splitting of lines in presence of magnetic field, which is also called Zeeman effect. Now, actually, when an electron is moving in an orbital motion around the nucleus, it generates an electric field. Because electron is negative, nucleus is positive, so when it revolves around the nucleus, it produces an electric field, and this electric field in turn produce magnetic field. So under the influence of external magnetic field, the electron of a subcell can orient in a certain region of space around the nucleus, and the electron which is orient in a certain region of space, that space is called an orbital, and this quantum number, magnetic quantum number, represent about the orbital. Actually, as you have got an atom contain a main cell, inside the cell some subcells are present, and inside the subcell the electrons are present. Now when the electrons are revolved around the nucleus, the electrons are revolved, it is moving around a certain region of space, and that space is called an orbital. I mean, inside the subcell some orbitals are present. So this quantum number represent about the orbitals. So the main cell contains subcell, and subcell contain orbitals. Now which subcell, as you have got the subcell sp, df, which subcell contain how many orbitals, you will get the idea from this quantum number. Actually, electrons are present inside the orbital. Orbital means nothing, it is a 3D space where the electrons are present. So an electron due to its orbital motion around the nucleus generates an electric field, which in turn produces magnetic field. Thus, under the influence of external magnetic field, which interact with the internal magnetic field, thus under the influence of external field which interact with the internal magnetic field, the electron present in a subcell can orient in a certain region of space, this is 3D space, around the nucleus called orbitals. So this quantum number represent the orientation of electrons. This is important, what it represent: orientation of electrons or the orbitals. Actually, inside the subcell, where the electron is actually present, where the electron is moving, that space is called the orbitals, and this quantum number represent about the orbitals. Now, if you want to find out the number of orbitals present in a subcell, you can find out like this. The values of ml can be determined from L values. I mean, each quantum number is related with one another. If you know the value of n, then you can find out L. If you know L, then you can find out the value of ml. So the values of ml can be determined from L values. For a given value of L, comma, ml have twice L plus 1 number of values. So this represents the total number of values. I mean, if the L value is 0, then you put 2 into 0 plus 1, I mean you will get 2. 2 into 0 plus 1, you will get 1. If L value is 1, 2 into 1 plus 1, I mean you will get 3. I mean you will get 3 values. This represents total number of values, and the values ranging from minus L to 0 up to plus L. So like this you will get the value. For example, if L value is 1, then minus 1, 0, plus 1, like that, up to plus 1. If the L value is 2, then it will start from minus 2, minus 2, minus 1, 0, plus 1, plus 2, like that you will get 5 values. So this represents total number of values, and these are the values. So I will give you the table, then you can understand how to find out the values. So from these values you can find out the number of orbitals. If you get 5 values, that means 5 orbitals are present inside the subcell. If you get 3 values, that means 3 orbitals are present inside the subcell. So this is the process how to find out the number of orbitals, and each value represent one orbital. For example, minus 1, 0, plus 1. Minus 1 represent one orbital, 0 represent one orbital, plus 1 represent another orbital. I mean 3 orbitals you will get. So like this way you can find out the number of orbitals. Now I'll give you the table. What is the value of n, then what will be the value of L. If you know L, what will be the value of ml. So like this we will find out the different orbitals. So in the next video we'll do that, we'll make that table. Thank you.